Our lecture today is going to be about space and the illusion of space. The first couple of terms we're going to learn about are positive and negative space. And the terms positive and negative deal specifically with three-dimensional art objects. This could be sculpture, ceramics, glassware, jewelry, and architecture. Positive space is defined as anything that can be seen, felt, or touched. Whereas negative space is just empty space, or we could even call it the void between the objects or their pieces or segments. Most artwork that's three-dimensional is going to have some type of percentages of both positive and negative space. And that's going to be true with the Watts Towers by Simon Rodea, an artwork we have locally here in Southern California. There's a video in the links below that you need to watch, and it brings you right to the Watts Towers. These towers are really cool. They're created in the 1950s by Simon Rodea, who was an Italian immigrant. We don't know a whole lot about him, but we do know that once he got hurt falling from these sculptures, that he had broken his hip, and then he left and moved up north to his brother, and we kind of lose him in the history of art. But he creates these really cool works. There's some railroad tracks behind the Watts Towers where he used that as leverage to twist these large bars of metal to create these rings. Overall, it's really fascinating work. It does have both positive and negative space. But that doesn't have to be the rule for all art objects. This sculpture here is entirely positive. This dates back to around 2500 BC, and we have King Menkari, who has one of the pyramids on the Giza Plain, and his wife next to him. This is a sculpture that's made out of diorite, so it's a very difficult medium in which to carve. So that's also why this looks almost brand new, even though it's 4,500 years old. We see a slight idea of motion with one foot standing in front of the other, but the area between the arms, the legs, the bodies are still solid. It would have been very difficult for the artist to carve these sections out, but we still have 100% solid sculpture. On the other extreme of that, we have this work here, which is 100% negative, where this artist took different tanks of gases out to the desert and released them into the atmosphere. In this case, this is helium that's being released. And so we have a completely void or empty space artwork. It is 100% negative. And it's also the only one I know that can attest to being 100% negative. When we switch over to two-dimensional artworks, we also have to change the terminology. Positive and negative becomes figure and ground. So when we look at artwork such as drawing, painting, photography, and printmaking, these we all consider to have figure and ground. This work here is a really cool photographic image that has both figure and ground to it, but as a viewer, we're mostly attracted to the figure itself. In this case, it's the letter R typed and then turned on its side. So we're attracted to the curves, the blackness, the solid form. However, for an artist, we are also concerned with the negative space, the whiteness, those other curvilinear shapes that we have in this form. So as an artist, none of these has seniority or more importance than the other. Positive and negative, figure and ground, they are all considered to be the same in terms of importance. Now we've got the term pictorial plane, and this is used a lot throughout art, and I just wanted to put this terminology in this lecture. Pictorial plane just refers to the surface of a two-dimensional artwork, whether it's a photograph, whether it's a wood panel, a canvas, illustration board, a piece of paper. That's the pictorial plane. And throughout history, artists are interested in piercing the pictorial plane, making that artwork look three-dimensional instead of flat and two-dimensional. In 1435, which is during the Middle Renaissance, this artist Leon Battista Alberti publishes this book called On Painting, where he states that looking at a painting should be the same as looking at a window. The book is also still in print today. It's that important of a book in terms of art. So artists all of a sudden have to come up with ways of piercing the pictorial plane. And we're going to take a look at 6 of these: scale, overlapping, vertical location, atmospheric perspective, amplified perspective, which is more commonly known as foreshortening, and linear perspective. The first one we'll look at is scale. Here, objects that are closer to us appear larger than those farther away. And so in this case, where we've got this really cool landscape scene with snow, we're looking at the trees on the left-hand side. And we can see that each set of trees starts to become smaller and smaller, and it leads us back into this painting, down this snow-covered pathway. So the scale of the trees at the left is altered. And this is the way we normally see. When we look at some of my past students here, they're at the Getty Museum, and we see Ibrahim at the left being the largest person. And then we move back to Rebecca, who's smaller, and Serene, who's smaller yet, to even that girl in the back, who we can barely recognize. The idea is that artists are replicating the way that we see, and scale naturally changes with the farther away the person is. So just like in our previous image of the trees on the left-hand side of this road, we see that they diminish in size, and that's exactly what the artist needs to capture in order to create an image that looks like the real world. Our next type of space is overlapping, which states that objects closer to us cover or hide objects that are further away. In this painting, in the lower left-hand corner, we have this bottle of apple juice covering over a bottle of water. We know absolutely that that apple juice is closer to us. Just like on the right side of the image, the very distinguishable bottle of Perrier is covering up another bottle. So objects closer to us cover or hide objects that are further away. And this is something we've really known since kindergarten. The same can be said for vertical location. It's one of those very inane ideas that all of a sudden we're drawing our attention to and we go, oh yeah, I totally understand this. With vertical location, the higher the object is on a canvas or on a board or in a photo, the further away it is from us. And this is something that is very common in Eastern cultures. We have this beautiful Japanese silk screen with irises on it. And we can see that this is a landscape image. The higher the object is, in this case the irises, the further away it is from us. So we have this beautiful scene that looks like we do have some creation of depth here because of vertical location. And we can even apply it to the Still Life by Tom Wesselman. The cans of coffee and the roast are closest to us. They're also at the bottom of the collage. Further up, we have the soda, camera, and beer. And then higher up yet, the furthest away from us, they're on the windowsill, is the apple and the lemon. And even back on this painting, we can see that the apple juice, the orange soda, and then the Martinelli's grape juice is all on different planes. The higher it is, as far as the grape juice goes, the further back it is. Now, when we start adding the word perspective, things get a lot more complex, a lot more difficult, but also a lot more realistic. The definitions become a lot more intense, but remember, for our class, we're not interested in the definitions. We're interested in being able to identify and apply these terms to an artwork. So during an exam, you're never going to be asked a definition. You're going to be shown images, and I'm going to ask you, is atmospheric perspective present here? So you do have to know about it, but you don't have to recall the definition word for word. The definition for atmospheric perspective states that as forms recede into the background, their contours become less distinct, and objects begin to take on the colors of the atmosphere. And again, kind of a dense definition, but this is what I want you to know, is when you look at this photograph, it contains atmospheric perspective. We look at the foreground here of the trees. They are crisp, they are clean, they are brightly colored, they are well defined. As we move into the background, though, those mountains become less distinct as far as their contours go, and the forms take on the color of the atmosphere. Those mountains in the very center that are the farthest back kind of look blue, just like the atmosphere. That is atmospheric perspective. Again, it's our eyes that are screwed up that the artist is trying to capture the way that we see. It happens in color, it happens in black and white, and it has to happen again in painting for the paintings to look realistic. With Lake Lucerne here, again, just like that photograph of Yosemite, we have a very clear, crisp, and well-defined foreground, but when we look at that mountain range to the back, we see it very distinct at the right, and then it's almost like we have a fog moving in. Those mountains become less distinct. The color starts to change. It looks very much like the atmosphere. And in some situations, you may not know where the atmosphere ends and the mountains begin and where there's clouds or snow. It can be very deceptive. Amplified perspective is more commonly known as foreshortening. And this is something you're not going to see very often. It is rare because it is very difficult to do as an artist. So this is when an artist purposely reduces or distorts parts of an object, but is still able to convey the illusion of three-dimensionality. And this is one of the images that I call a textbook image. When you see this on the exam, the answer is foreshortening or amplified perspective. It is used in all the art history books. Andrea Mantegna was a Renaissance artist during the 1400s and was wonderful at creating foreshortening. It is a very difficult task for the artist to do and to do well. What the artist has done here is he's shortened up both the legs and torso of Christ and elevated the body out of linear perspective, which we will learn about shortly, to present this image to you. So if he had painted this image correctly, we wouldn't be able to see the body of Christ because his feet would have been in the way. This is a contemplative work at the left. The idea is that we want to see and dwell on the wounds of Christ. This is a painting that would have been presented in a small church or chapel, and you would sit in front of it. However, with this painting, it brings us in at a very unique angle, and that's usually what foreshortening is about. It provides us a very unique point of view or perspective for this work. There's no other painting I know that brings us in literally standing at the feet of Christ. Another work by Mantegna that utilizes foreshortening is in this beautiful ballroom in Florence. And when you look up at what is the ceiling, all of a sudden you see that there's really like an aperture with people looking back down at you. And all of these figures here are foreshortened. Another work where we have this angel flying out above us from our space, or sitting at the very end of a rowboat in a Mary Cassatt painting. And we even have foreshortening in photography. Again, think about the unique angle that the viewer is being placed at. And now we're going to move on to linear perspective. Linear perspective is the most convincing way of representing three-dimensional space on a two-dimensional surface. Now we have some good news, is that linear perspective is nothing more than a math equation, which means that we can all easily follow it. The bad news, though, it is a math equation, and not all of us are great in math. And think about it this way as well. How many correct answers are there to a math equation? There's only one. So this has to be done correctly, or the entire work is going to be off. Now, linear perspective was first figured out, codified, put a formula to it in the early 1400s by the artist and architect Filippo Brunelleschi, who you see here at the left. It revolutionized art overnight and became the gold standard that artists had to live up to. Basically, you had to know linear perspective, and if you couldn't master it, you weren't going to be an artist for very long. Now, in 1863, when we start to talk about modern art, this is where modern art begins, we move away from linear perspective. But for the next 400 years, linear perspective is going to be really the only way to create art. The theory is pretty simple. It's that parallel lines appear to converge on or emerge from a single point in the distance, and that point is called the vanishing point. So the best way I can tell you or explain to you how linear perspective works is through train tracks. And if we're up here in Alaska, this is where this photo is taken, and we're traveling about 100 miles an hour on this train, what do? Because you can see that the tracks that should be parallel are not. They're coming together at a point in the distance. That point is called the vanishing point. So as an engineer on a train, do you press the emergency brake because you see the tracks coming together? Or is this another point where we realize our eyes are screwed up, that they are bringing parallel lines together? And that's exactly what happens. Our brain tells us to relax, that our eyes are messed up, that these tracks are parallel, and everything's going to be fine. It happens to us on airplanes. It happens to us in Star Wars as we go through light speed. And if you don't like Star Wars, that's okay, because it happens in Star Trek also. Parallel lines merge at a point in the distance called the vanishing point. So how do we create this? Well, the first thing we do is set up a horizon line. A horizon line is going to stretch across the canvas, or sheet of paper, or piece of wood. It's where the sky and the land are going to meet. The horizon line is one of the few truly straight lines that we have in nature. And it does extend past the frame infinitely in either direction. So it doesn't ever stop really at the edge of the artwork. It continues on infinitely in either direction. And that'll come into play later when we start to look at some of the more advanced artworks. So here we have our horizon line. Again, just a horizontal line across the canvas. This is an arbitrary line. It can be up higher, as we see in these train tracks. It can be down low, as we see in this landscape painting. So it's up to the artist to determine where the land and the sky are going to meet. Step 2 is just as simple. It is to place the vanishing point on the horizon line. That's where it's going to live. Now, the vanishing point is also an arbitrary position in space. It can be located in the center of the canvas, and that means that the work is in frontal recession, and it's going to be a very balanced work. Or it can be off-center, whether to the left or to the right, and that means it's diagonal recession, and it's going to create a very asymmetrical artwork. And don't get too caught up into these definitions right now. It'll be a lot more clear when we look at some examples. So with the work at the left, we can see that the vanishing point is in the center. That's where these train tracks are headed to. In the work at the right, we have the train tracks still, but that vanishing point is not in the center. It's off to the right. So we have a completely different point of view of this scene. And it's all determined by where the vanishing point is placed on the horizon line. And you can see even from side to side, these two works have roughly the same horizon line. The key thing to know about the vanishing point is that this is where all the parallel lines are going to converge. If this fails to happen, the work is going to be wrong. It's not going to be in linear perspective. So keep in mind that the parallel lines are going to meet at the vanishing point. So there's our horizon line, there's our vanishing point. So step 3, all parallel lines must be drawn in such a way that they converge on or emerge from the vanishing point. Doesn't matter which way the lines are going, toward the vanishing point or away from it. So now we have to memorize that lines that should be parallel, such as all those railroad tracks we looked at, are no longer going to be parallel. They're going to be slightly angled. The very first work that was done in linear perspective, I should say the very first painting, is in Florence. It's at the Santa Maria Novella. And as we enter through this church and pass through the congregation, we're going to make a left at the pulpit and see this work against the wall. This is done in fresco, which means it's part of the wall itself. It's done when the plaster is still wet. And the painting is gigantic. It's like 20 feet high and roughly 10 feet wide. This is, as I mentioned, the very first painting done in linear perspective, and it drew a tremendous amount of people to come see it. It is by the artist Masaccio, and Masaccio, even though he's not famous today in normal circles, he's very famous in terms of Renaissance art. This is the person who inspired Michelangelo. As a kid, Michelangelo would go to the Brancacci Chapel in Florence, and he would copy the works of Masaccio that were painted on the walls. But here, Masaccio creates this great image of the Holy Trinity. And this work is absolutely in linear perspective. We have God and the Holy Spirit. We have Christ at the foot of the cross, Mary and John. And then outside the scene, we have the patrons, which are the people who paid for the work of art to be produced. We can prove that it's in linear perspective. When a work is already completed, we can work it in reverse. So we can draw lines, and we're looking specifically at architectural features to help us the most. These lines from the barrel vault that's behind the crucifixion are tapered. They meet at that single point that lets us know where the vanishing point is. And of course, the vanishing point lives on the horizon line. That's where the two patrons are situated, and we know that we're correct in our drawing here. Prior to linear perspective, and this is by another famous artist of the Renaissance, in fact, what I would consider the very first artist of the Renaissance, the artist Giotto. And he creates this scene that he tries to give us this realistic image of space, but he kind of fails at it. The buildings look funky. Even that building at the left, over that walkway, that stairway, that covering looks like it's about to fall down from dry rot or something. And when we draw lines from all the architectural features, we see that they do not meet at a single point in the distance. They kind of go haphazardly from the right side to the left side of the screen. So this work is done roughly 100 years before linear perspective is created. One thing to note too, especially to help you on an exam, if you kind of know the time period of when a work is completed, it already answers your question as to whether or not a work is in linear perspective or not. In the case of The Last Supper by Da Vinci, we know that it's completed in 1495 through 1498. It's after the invention of linear perspective. It's before 1863 in terms of modern art beginning. So without even having to guess, we know that this work is going to be in linear perspective. It also looks like a real room. And if we're forced to prove that it is, we can do that absolutely by drawing lines. Again, we can look at the coffered ceiling. We can look at the doorways on either sides. All those lines line up to a vanishing point right at Christ's forehead. The edges of the table also go to that single point, and that also lets us know where the horizon line is. Now, before I move on to this image, I do want to point out that here the vanishing point is in the center of the work, which means that it's in frontal recession, and it is a very well balanced work on either side. It's what we would call symmetrical balance. This work is also in linear perspective. However, here that vanishing point is slightly off to the left. The work is asymmetrical, meaning that the left side and the right side don't really match up, but the two balance each other out still. But we can see that the trees, the park benches, the sidewalk, the street, they're all in linear perspective. Now, this is what's called one-point perspective, or sometimes called scientific perspective, which means that there's just one vanishing point. It's not very exciting. It's fairly easy to do. In fact, we're going to do this together on a class project. But when we add a second vanishing point, it opens up a lot more possibilities to an artist. Consider the work at the left. It's a very frontal scene. It's very much like a Last Supper image. But when we look at the possibilities of the right image, we can have a whole lot more fun with two-point perspective. Anytime we see a building like this, we can say it's absolutely in two-point perspective. And this is because it is at an angle. If this was a one-point perspective work, we would see the building straight on. But because it's at an angle, we know that we have two-point perspective. If we follow the roof line down to the horizon, we can see that there's going to be a vanishing point right off at the right corner of the work. When we look at the left-hand side of the image, and we can see that the tops of the gas pumps, again, we can follow the ceiling down, we're going to have another vanishing point, but this time it's not going to be on the canvas. It's going to be way off to the left, about a couple of inches off of the canvas. And remember, this is because the horizon line extends past the canvas infinitely in either direction. So with this work, we have two-point perspective. We can also see that the horizon line is very well at the bottom. And of course, tying in that the vanishing points live on the horizon line. Now, Ed Ruscha was a Southern California artist, and he loved painting this gas station, even though the gas station was in Texas. And he paints it during the day, and here he paints it at night. He even paints it on fire. And one of my favorite works, this is the one he does called The Double Standard. Now, let's go back in time a little bit and look at this painting from the late 1800s. It's by Gustav Klimt, and he's one of the late Impressionist painters. He's got this painting that completely depicts this wonderful spatial scene. Everything we have studied over the course of this lecture is enveloped here in this painting. When we look at scale, objects closer to us appear larger than those farther away. We can see the scale variance in the individuals in this painting. From the two people walking right at us with the umbrella, to the left of that we have a smaller individual, smaller yet to the left, and then even in the background we have smaller individuals. So we have the variance of scale here. Overlapping. The two individuals at the very far left of this painting, one overlaps the other. We also had vertical location. The higher the object is, the further back it is. And again, when we look at the different sizes of these individuals here, the people coming at us, their feet are going to hit a couple feet underneath the edge of the frame. The person to the left of them is higher up on the canvas. The person to the left of that is higher up yet. So vertical location is used here. That building in the back is in linear perspective, and it's in two-point perspective. And here I can use some lines to show you that even the individual floors of this building are going to connect down to these vanishing points, one on either side of the building because it is at an angle. So we know it's two-point perspective, and we can therefore determine the horizon line. So we've covered one-point perspective, two-point perspective. It gets worse. Multi-point perspective. When we have three or more vanishing points, we have a multi-point perspective work. However, generally the horizon line is only strong enough to hold two vanishing points. So that third point has to be above or below the line. And what happens is it gives us very unique angles, looking up as if we're far below an object or that we're far above an object. This is not something we're normally going to see and do as normal everyday artists. This is for someone who is very, very dedicated to this process. And when we look at works by M.C. Escher, these are works done in multi-point perspective. M.C. Escher, much to my sadness, is not really embraced by the art world. Most of the time, I think, because they're jealous, because they can't do something like this. M.C. Escher was not a full-time artist. This person was a math professor. And remember back to when we first learned about linear perspective, I told you this was a math equation. And this is something he would have really enjoyed. So those two elements together make this image what it is. It is a highly enveloped math equation done through the use of linear perspective. And with that, this is where I'm going to leave this lecture. Don't forget to check the links in the description for videos you also need to watch to support this video.